All right, so I want to go over a few, or actually quite a few, definitions that you're going to need to know for the next week and a half or so. So like you just to fill in the blanks. And when you come to school tomorrow, I'm going to give you another packet with things, with these definitions in depth, okay, that we're going to be working on for the next couple of weeks. All right, so number one says the domain. So the domain is the set of x values for which the function is defined. So right in here, you already have the word value, so you just want to put x values for which the function is defined. All right, number two says the range. You might remember this from domain and range from algebra. Domain of the x values. The range is the set of all the y values of a function. So put y values. And number three is the minimum or minima. That is the smallest value of the function. So right in here, you're going to put smallest value. All right, number four says the maxima or maximum is the largest value of the function. So right in here, put largest. So minimum is how the lowest that a function goes, and maximum is the largest, how high up the function will go. All right, let me just get rid of this now. All right, so number 5, where it says increasing. So number 5 says increasing is the intervals of x values that cause the function, the y values, to increase or to go up. So increasing is the intervals of x values that cause the function, that would be the y values, to increase. Okay, or in parentheses, you could put here, go up. All right, and number 6 says decreasing. That's the intervals, and I say intervals because it could be more than one, of y values that cause the function, the y values, to decrease or to go down. Okay, so flip your page over to get to number 7. Okay, it says the roots /0. So this is very familiar. We've been working with this since the beginning of the year. If it satisfies the equation, now I'm going to put down the equation of a parabola, quadratic, ax squared plus bx ax squared plus bx plus c equals 0. Now, we've also been working with other polynomials, so this is not, these roots, these zeros, are not just for parabolas. So right above it, put all polynomials. Equations or functions. Okay, all polynomial functions. The intersection between the graph of the function, the graph of the function with the x-axis. So remember, the roots, the zeros, is where the graph crosses the x-axis. And number 8, the intercepts. So we have two different kinds of intercepts. We have x-intercepts and we have y-intercepts. The x-intercepts are where the graph crosses the x-axis. Okay, that would be where your y values are equal to 0. And your y-intercepts are where the graph crosses the y-axis. And where it crosses the y-axis, it's where your x value is equal to 0. So x-intercept cross the x-axis, y is equal to 0. y-intercept, where it crosses the y-axis, your x is equal to 0. When you have intercepts, you have to make sure it is written as a point. Okay? All right, and let's see here. Next. Move this up. Okay, number 9. Even function. Even function is the function is symmetrical. This is going to be a little long, so I'm going to have to write over it. Symmetrical. About the y-axis. So you can put down here f of x, your y value, is equal to opposite of your x value. That's f of negative x. So your y value is equal to opposite of whatever your x value is. So if your x value is negative 5, your x value is negative 5, your y value is positive 5. All right, odd function has rotational symmetry. With respect to the origin. Rotation of 180 degrees about the origin. So you remember back in geometry, rotational symmetry, 180 degrees is when you turned your paper upside down. That's rotational symmetry. Symmetry is when you can fold it along something, you get the same exact thing on the other side, the mirror image. All right, so for odd function, it's negative f of x, so negative your y value, is equal to negative of your x value. All right, and the last one is end behavior. End behavior is the behavior of the graph of f of x as it approaches positive infinity or negative infinity. Okay, so end behavior is what's happening at the ends of your graph. You know, does it keep going up to positive infinity? Does it keep going to negative infinity? And so on. All right, so tomorrow we are going to work on finding some of these key features, your max, your min, your domain, and range. And next week we'll be working on some other stuff, some of these key features also. All right, everyone, have a good night. See you tomorrow morning.